Okay, I have a cannonball that's being shot out. I'm asked to draw a simple diagram. If you read the objectives, you have to double the time. That helps you move between the axes. I have 30-degree angle. The cannonball shot up. I redrew it over here. It's going at 40 meters per second. That's the full velocity initial. But we need to know the x and the y components. So how do I know that this one's sine and that one's cosine? Well, you could also look on your physics reference table. There's A's here, but I switched it to put V's. So these are vector components. The vector component of the y, or the velocity component of the y, is the sine. The vector component of the x is the cosine. It's kind of a quick summary. Other way to know is to kind of set up this little chart with trigonometry or geometry, wherever you look at. Oh yeah, we're going to lovely get this. All right, so I put some white out here because I'm going to make these a little bit clearer. But I'm doing the cosine. This is 30 degrees. The cosine of the angle says take the adjacent side. And what is this? This is V initial in the x, the component of 40 that goes in the x. So it can't be the full 40. It's only part of it. And this is the component initial, the full 40, with just a little piece of it. So I want to put the y component. I'm waiting a bit for it to dry. So now I have to do adjacent, which is this side, over hypotenuse. So I'm going to put V initial x. So I put the cosine of the angle, which I know is 30. The adjacent, V initial x, divided by the hypotenuse, which is 40. I've got to solve for that. So I multiply 40 by both sides. 40 by both sides. V initial in the x is 40, cosine 30. Now for the sine of the angle, it's opposite, which is that one divided by the hypotenuse, just making it a little clearer. So then you would have, do the sine of theta, which would be V initial, would be opposite V initial y. V initial y component, divide by 40. Multiply 40 by both sides. Now the 40s cancel out. So V initial in the y is 40 sine. Oh yeah, that's what I can put that 30. That's how I got these numbers, these components. Just saying. All right, now let's see if we can fill in this chart. There is never any acceleration. Even though the ball's going up and down, like it's slow, it's deaccelerating going up and accelerating when it goes down. Horizontally, there's no movement. In the y-axis, just going up, it's negative 9.8 meters per second squared. Going down, same thing, negative 9.8 meters per second squared. So we're going to have to break this up into like 3 parts. Man, you guys are going to be amazing. Now we can do the x, hold on, the velocity in the x-axis. Put that in a calculator. Let's put that in the calculator. Velocity in the x-axis, 40 cosine, make sure you're in degrees, by the way, make sure you're in degrees, 40 cosine 30. V initial in the x is 34.6 meters per second. 34.6 meters per second. And that never changes. Put that twice. Same. The velocity going this way, no matter what I look at, it always has the same velocity. Even right before it hits the ground. Same velocity vector, same length arrow. That always stays the same. All right, now going up, the initial velocity that makes it go up to the sky. Solid cannonball, I guess. I'm going to put in 40, partial of 40 meters per second, sine 30. So I do 40, now I do the sine 30, 20. Okay, that was an easy one. Unit meters per second. So initial going up is 20 meters per second. Drag it. I need 3 things. But what do you know about a ball that goes straight up and straight down? In the y-axis, the V initial in the, the V final in the y-axis right at the top is 0. Because it stops right before it comes right down. And then if you look at it going down, so going up, this one's 0. And then going down, the V initial in the y-axis going down is 0 here. And what do we know? There's symmetry going on here, so that's going to be negative 20 meters per second. Whew, happy to know about the things. All right, now we can rock and roll. That's why this, physics is not for the trivial. You guys are doing amazing. Can we do this? Rock and roll. Happy to know about the things. Now, this is, whew, I just keep, once we do this, we're done, guys. All right. Woo, let's go. I need my dy. That's the max height. Max height, right? Max height. All right. All right, so I got my new reference table. These are the ones we're looking at. We've been hanging out here for a while. Now, I don't have time. Gotta find time. So I'm going to skip ones with equations of time, and then I'm trying to look for max height right here. That might be easier than trying to do the other stuff. Maybe I can do this one. Oh, that might be easy. Do time here. Let's just check. I guess I can do it either way. Yeah, V initial, I'm given. V final is 0. I know gravity. Oh, I can do time. There we go. We'll do that one. That's much easier. So V final equals V initial AT. So we're just doing this stuff. This is y-axis up. V final is 0 because that's right before it falls back down. V initial is only 20. It's not the original 40 because only part of it went up, so it's going to be less than that. 20 plus negative 9.8 t. Subtract 20 from both sides. Get negative 20 equals negative 9.8 t. Divide by 9.8 both sides. Negative 9.8 both sides. You don't need to put parentheses. That's just for clarity's sake. Double negative makes it positive. That cancels out. My t equals, I usually put the t on this side. Go 20 divided by 9.8. Divide by 9.8. 2.04 seconds. What do I want to do? Do I want to round or keep it? Well, if you want to be very precise, you probably do the 2.4. But for my sake, I'm just going to put 2 seconds. You want to do 2.4, you're going to get a little different answer, but we'll do that. All right, now, what do I know? It goes up at 2. So the arcing goes up at 2. Yeah, maybe I better put 0.4. I don't know. 0.4. And then it goes down. Goes down at 2.04. So the total time, just to let you know, is going to be 4.8. 4.8 seconds. Yeah, I just want to be a little clearer on that one, I guess. All right. Now I got to find dy. Yeah. So time up plus time down, 204. Up, then down. That's what happens in the cannonball. So I guess it's a bigger arc this way. Whatever. Now I got to find the total height. What's the height? Still the y-axis up. Y-axis up. I do dy. I don't know. Let's see. Which one's good? Well, that one's going to be annoying because there is initial velocity. That one's going to be... Yeah, I might do this one. This one's probably easiest because that's a 0 right there. Yeah, that's a 0 there too. Oh, no, it doesn't have a d, so I have to do this one. I'm going to go V final squared equals V initial squared plus 2AD. The V final is 0, so I have 0 equals, what's my V initial? That's that 20. I square it, don't forget to square it, plus 2 times negative 9.8, and then D. That's 0 equals 400 plus, what's that, 19 points. Let's do it. 2 times 9.8, 6, D, that's supposed to be negative there. Subtract the 400 from both sides. The 19.6 is multiplying to the D. The 400 is adding to the D. So I'm subtracting 400 from both sides. Negative 400 equals negative 19.6 D. Divide by 19.6. Both sides. Negative 19.6 by both sides. That cancels that out. Then I'm left with D equals 400 divided by 19.6. D equals 20.4. That's kind of weird. That's just going. That's 2 seconds. This is 20.4 meters. 20.4 meters. That's going up. It goes 24.4 meters down. So going up right here is 20.4 meters high. Max height. Max height. Whew. All right, what's the time that it was in the air for? Double it. So it's 204 plus 204, which is 408 seconds. What's my dx? Oof, now I'm just doing my dx. All this stuff is still 0 because A is 0. So I'm going to do this one. My dx, I'm just going to squeeze this in right here. My dx is V initial t. My V initial is 34.6 times my 4.08. Multiply those two numbers together. Take 0.408 times 34.6. I get 141 point, I'm going to round up to 2 meters. Went pretty darn far. For like almost a football length and a half. Wow, that's a lot of stuff. There you go, guys. Woo.